heart, but meantime, sound of the river, you stop and you hold.
Okay, today we're going to finish off section 1.2, which is on set theory. Shorter video this time, not as many terms to know. But two very important terms to know are intersection and union. So the intersection of two sets, let's talk about set A and set B. The intersection of set A and set B, we also just say A and B. Remember, capital letters often refer to sets. So we're interested in and remember in the first video in this chapter we talked about what and means in set theory. What that would mean, A and B, is the set of elements that are members of both set A and set B. It has to be an element that's in set A, but it's also found in set B. And the way we represent this is we say A and then this kind of upside down U, B. This is A intersection B. Okay, so we'll give you some examples of that in just a little bit here. The union of set A and B. This is the OR. Remember we talked about special words and we talked about OR, and we talked about with OR that there's two different types of OR. There's exclusive OR and there's inclusive OR. And what we said is in mathematics the OR is going to be the inclusive OR. So do you remember what the inclusive means? It means it could be A, or it could be B, or it could be both. So in this case, the union of set A and set B, it means the set of elements that are members of set A, or they're members of set B, or they're members of both. So as long as they show up in one of them, we include it in the union. And the way we show that is A, U, B. That's the union of set A and set B. And then the last thing we're going to look at today is disjoint sets. And disjoint sets are two or more sets that have no elements in common. Right? There's nothing that they have the same. So for example, if one set has ABC in it and another set has DEF in it, then those are disjoint sets. So the intersection, in other words, remember we just talked about intersection up here. It's the set, the members that are in both sets. What's the intersection of two sets if they have no elements in common? Well, if they have no elements in common, the intersection is the empty set. There's no elements that are in both sets. Okay, in such a case, in a disjoint set, and, remember what the and means? It means the number. What's the number of sets in A, the intersection of set A and B? We just kind of talked about this. If you looked at the intersection of set A and B and their disjoint sets, it would be the empty set, right? So what's the number of things in the set? The number of things would be, how many things are there in the empty set? 0. So the number would be 0. Okay, what's the number in the union of these two sets? So remember, all the elements in A and all the elements in B are different. So if you want to know the number of elements in the union of A and B, it would literally be the same as the number in A. How would I finish that off? It would be the number in A plus the number in B. Because there's no overlap, you could just add those two things together and you would get the number in the union of A and B. Okay, let's do some examples, and for these examples we're going to use these four sets right here. The first set is the universal set, and in this case the universal set is going to be the natural numbers less than 15. And just so we can picture this, we're going to write it out, but I don't know, this one's probably not necessary to write out. Natural numbers less than 15. What do the natural numbers start with? 1. So we go 1, 2, 3, and I keep going dot dot dot, and I finish with 13, 14. Do I include 15? No, because it has to be less than 15. So this is the first one right here. The second set is set A, and it is odd numbers less than 15. So let's write them out here just to help us. 1, 3, 5, 7, 9, 11, 13, and it has to be less than 15, so that's it. The next one, B, set B, is prime numbers less than 15. 1 is not considered a prime number, so 2, 3, 5, 7, 11, and 13 are all prime numbers less than 15. Boy, those brackets are bad, those curly brackets. And the last one, I don't think I need to write it out, but maybe I will just so we have them all together. It's just the elements 5, 7, and 11, and 12. Those are our four sets that we're looking at here. And the first thing we're going to do here is we're going to find the union of sets A and B. So, do you remember what union is? Union is the set of elements that are members of either set A or set B or both. So either they're in this set, because this is set A, or they're in that set, or they're in both. Now if they're in both, you don't write them twice, you just write them once. So basically all we have to do is write every single thing that shows up here, but if it shows up twice, we just write it once. So I can see a 1, I can see a 2, I see 2 3s, but I just write 1, 3, 2 5s, just write 1, 2 7s, just write 1, I see a 9, I see 2 11s, just write 1, and I see 2 13s, just write 1. That's the union of A and B. Okay, for the intersection of A and B, we're looking at these same two sets here, but now for the intersection, we're looking for the set of elements that are members of both sets. They have to be in both. So I see a 1, but only in the set A. I see a 2, but only in set B. I see a 3 in both, so that's part of the intersection. What else shows up in both? 5 shows up in both, 7 shows up in both, 11 shows up in both, and 13 shows up in both. So this is the intersection of A and B. Alright, we're going to do the union of A, B, and C. So in other words, any number that shows up in any of these three sets, you're going to write them down. So it's going to be exactly the same thing as this, because that's the union of A and B, but we're also including C. So is there any other numbers that show up in C? Well, we already have a 5, we already have a 7, we already have an 11, but we don't have a 12. So it's going to be exactly the same as what we did up here, but now we're going to also include a 12. So kind of lousy to have to write all this, but 11, 12, 13. There you go. That is the union of all three sets. If we want the intersection of all three sets, we need to look for numbers that show up in all three of these. So we have 3, 3, but no 3 here. 5, 5, 5 works. 7, 7, 7 works. 11, 11, 11 works. And that's it. So we have 3 elements in this case. They are 5, 7, and 11. Okay, now we get to some a little bit more difficult questions. This one, you're going to do the brackets first. That's the way math works, right? We're going to do the brackets first. We're going to get the union of A and C. So let's do that first. A and C, and we want to get the union. So the union means we write down all the numbers that show up, whether they show up in one or both of the sets. So we're going to have the 1, 3, 5, 7, 9, 11, 12. Oh, so the only number, it's basically set A plus the number 12. So I'm going to write that. This is kind of a drag. 1, 3, 5, 7. So all the odd numbers plus 12. So I'll write that here. We have 1, 3, 5, 7, 9, 11, 12, and 13. And then we're going to put that prime sign there. And remember what that prime sign means? The prime means we're looking for the complement of that set, and the complement, it's all the elements that are not in this set but are in the universal set. So does that make sense? In the universal set we have all the numbers from 1 to 14. So what we need to do now, if we're going to take the complement of this set here, is just write down what are the numbers that do not show up in this set here between 1 and 14. So I see no 2, I see no 4, I see no 6, I see no 8, I see no 10, there is a 12, and I see no 14. This would be your answer here. So this is your final answer. Okay, this time we're going to do the complement of A and the complement of C first, and then take the union of both of those. So for the complement of A, here's A, this first highlighted one, and we want to write down all the numbers that are in the universal set that don't show up here. Well, that's going to be all the even numbers, isn't it? So we have for A complement, we have 2, 4, 6, 8, 10, 12, and 14. and then the union of, okay, for the second one, the complement of C. So all C has in it is 5, 7, 11, 12. We have to write all the numbers from 1 to 14 except for 5, 7, 11, 12. So I hope I can remember that. 1, 2, 3, 4, no 5, 6, no 7, 8, 9, 10, no 11, no 12, 13, 14. And then we want the union of this. So any number that shows up in at least one of these sets or in both of them also works. So is there anything that doesn't? We're not going to write down. We're going to have a 1, a 2, a 3, a 4, no 5, a 6, no 7. Why don't I just do this instead of saying it? 1, 2, 3, 4, no 5, a 6, no 7, an 8, a 9, a 10, no 11 in either one of them, a 12, a 13, and a 14. That is your answer to this question. All right, next one. Start with the brackets. So we want the union of B and C. So anything that shows up in the bottom highlighted one or this one here. So 2, 3, 5, 7. We already have the 5, 7, 11, and 12. So basically it's the same as B, but add 12. So 2, 3, 5, 7, 11, 12, 13. Can I remember that? 2, 3, 5, 7, 11, 12, 13. And I should have written that over here. Okay, so that is the first bit. And now what we're going to do is we're going to take the intersection of that in A. And remember that A was what? All the odd ones? Yeah. It is 1, I'll just rewrite it, 1, 3, 5, 7, 9, 11, 13. And we want the intersection, which means the ones that show up in both. 1 doesn't show up in both, 2 doesn't, 3 does, 5 does, 7 does, 9 doesn't, 11 does, and 13 does. So those 5 elements are the ones that make up our answer for this question. And the final one, we want to start with the intersection of B and C. So we're looking for numbers that show up in this highlighted one and the one below it. It has to show up in both of them, right? If we're looking for intersection, it has to show up in both of them. So I see 5, 7, 11. That's it. 5, 7, 11 are the only ones that show up in both of those. So I'll start by writing those down. 5, 7, 11. Gosh, those are some scary braces or curly brackets. And then we want the union of, oh, now it's the complement of A. And remember, we did the complement of A here. The complement of all the odd numbers is all the even numbers. So I guess I could write it again. 2, 4, 6, 8, 10, 12, 14. And if we want the union of those, we write down all the numbers, whether it shows up in one or both of these. So I see we have a 2, a 4, we got a 5 over here, a 6, a 7, and 8. What's next? A 10, 11 over here, 12, 14, and that should be it. So this is our final answer here. I think it's definitely going to be worthwhile to do this little extra work by writing these. Trying to do all of this in your head is a pretty good recipe for getting the question wrong. So I invite you to try to do it this way. Have fun with the homework. I like it. It's kind of fun. Take care.